The Chemistry Book. Big Ideas Simply Explained by DK Publishing.
Oh no. Somebody called police. Oh.
Introduction.
Just knocked that girl off on the floor.
Introduction. Chemistry can be defined as the study of the elements and compounds that make up ourselves and the world around us, and the reactions that transform their multitude of substances into different ones. But to define it so simply diminishes the mystique and wonder of chemistry, which has repeatedly drawn people to study it over the ages. Chemistry is the science of flare and spectacle. Two colorless liquids mixed together produce a blooming bright yellow cloud of precipitate, a sliver of shimmering metal dropped into a bowl of water, bubbles and bursts dramatically into an ethereal lilac flame. Outwardly left unexplained, these reactions have the appearance of magic. However, unlike magic, chemistry has surrendered its secrets over the centuries, although some of the tools required to probe them may be complex, and as our knowledge of chemistry has developed, so have our perceptions of this science. It is the great beauty of our science, chemistry, that advancement in it opens the door to further and more abundant knowledge. Michael Faraday. From alchemy to chemistry. In ancient times, the discipline that would become chemistry began as a practical means of separating and refining substances, driven by the recognition that the components making up a mixture could have different properties. Early practitioners of these techniques in Babylon, China, Egypt, and Turkey developed specialized equipment to better refine their processes. Some of these methods, such as those to produce soaps, make glass, and refine metals, are still used in modified forms today. In medieval times, the practice known as alchemy held a promise of riches and immortality. The alchemists tirelessly sought the legendary philosopher's stone, a mythical object purported to have the ability to turn common metals into gold and allow creation of an elixir that would give the drinker immortality. Though these lofty goals would be unfulfilled and may raise eyebrows today, the alchemists' work in pursuing them led to the development of experimental chemistry and even to the discoveries of new elements. By the 18th century, something resembling modern chemistry was beginning to emerge from the increasingly disparaged practice of alchemy. A revolution in chemical thinking led to clearer ideas about proportions in which substances react with each other and combine. The 19th century saw the founding of modern atomic theory, as well as the emergence of chemistry's most recognizable visual representation, the periodic table. It also saw an explosion of industrial applications for chemistry, transforming the science into a technical discipline that made innovations possible. The 20th century witnessed the realization of these innovations. Plastics, fertilizers, antibiotics, and batteries are essential parts of modern life as we know it, while few inventions can claim to have affected such colossal societal change as the contraceptive pill. But there were also warnings of the power of chemistry and its potential for harm. The extended use of leaded gasoline and its potential impact on neurological health, the damage done to the ozone layer by ozone-depleting compounds, and the advent of nuclear weapons were all reminders that chemicals can be dangerous as well as beneficial. Today, our relationship with chemistry is an uneasy one. It continues to provide vital and life-saving innovations that constantly extend the boundaries of our knowledge. Most recent, the CV-19 vaccines are dependent upon the chemistry that underpins them, but there is also continued concern about the impact of chemicals on our health, climate, and planet. Ironically, to solve these chemical problems, we will rely on solutions from chemistry in combination with the other sciences. The divisions of chemistry. It has become customary for modern chemistry to be split into three broad divisions: physical chemistry, organic chemistry, and inorganic chemistry. Physical chemistry is at the interface between physics and chemistry, commonly involving the application of mathematical concepts to understand chemical phenomena. Its aspects include thermodynamics, which chemists can apply in order to discern the stability of chemical compounds, whether or not certain reactions take place, and the speed with which reactions happen. Organic chemistry is the study of carbon-based compounds. Carbon is unique in its ability to form large networks of bonds with other carbon atoms and atoms of different elements, such as oxygen, hydrogen, and nitrogen. Biological compounds, including our DNA, are organic compounds, as are many of the medicines we use. Organic chemistry is concerned with the understanding the structures and reactions of these compounds. Finally, inorganic chemistry deals with compounds outside organic chemistry, including compounds of metals, determining their structures and how they react. Advances in this area have led to the creation of pigments, new materials, and lithium-ion batteries that power many of our modern devices. While textbooks and chemistry classes still commonly organize chemistry into these divisions, increasingly the boundaries between them and between chemistry, biology, and physics have become blurred. Many of the biggest scientific advances in recent years, the use of particle accelerators to create new elements, genome editing, and the COVID-19 vaccines transcend these simple classifications and require expertise from across the scientific disciplines. Chemistry has become the central science, intersecting with the other sciences to deliver new and exciting advances. This book charts the course of this evolution, beginning with chemistry's practical roots in ancient times, recounting the emergence of modern chemistry from alchemy, and ultimately uncovering how chemistry's reach is extended to touch almost every aspect of today's world. Chemistry provides not only a mental discipline, but an adventure and an aesthetic experience. Sir Cyril Hindgelwood.